In this video, I will discuss and demonstrate model transform from a Creo assembly model to a Cameo SysML model, including compare and sync functionality. The normal use case is that a CAD designer has created a CAD model of a new assembly and wants to create a SysML block with part properties corresponding to the CAD assembly parts and value properties corresponding to assembly mass properties. These properties could be used to check the current design against requirements. The designer also wants to be able to update the SysML model when the CAD design changes, so that the SysML model reflects the latest design. I have a Cameo model with an empty package called Demo Creo. This will be the destination of the CAD model transform. Note that the SysML model includes the Syndea profile. I launch Syndea as usual from the demo package, and go to the Connection Manager tab. I open the SysML repository link in the left column, and a repository link on the right side to our local file system. I drill down to the tutorial package and find a sample assembly model. There are multiple versions of this, with numbers appended to the end of the file name. Note that this symbol represents the file containing the CAD model, not the model itself. If my sole objective is to create a traceable link from a SysML element to the CAD file, I can choose Reference Connection in the central column and drag the SysML element onto the top of the CAD file icon, or vice versa, to create a reference connection. If I want to see the CAD model inside the file, I must have access to a Creo parametric license. A Creo parametric license is required because, as with all other Syndea interfaces, Syndea has no access to system data unless the user does. See the Syndea user guide for more information about the Creo installation requirements. With that Creo parametric license, I can expand the file and see the model contents in the Syndea browser. I can right-click on the sample assembly and open it in Creo. For this example, I have already created a simple CAD assembly for a peg and base, saved on my local drive. Alternatively, I could access the CAD model if it were managed in the Windchill PLM system, but this does require that I have both the Creo and Windchill interfaces for Syndea. Accessing the Creo file in my local directory only requires the Syndea Creo interface. If I wish to pull the Creo model into SysML, I set the center column to Model Transform and drag Sample Assembly onto the Demo Creo package. Very shortly, we see the part structure of the assembly on the SysML side. If I expand the SysML assembly block, we see that it contains two part properties corresponding to the two parts of the assembly, plus several value properties reflecting the mass properties of the assembly. Mass properties include mass, volume, surface area, and density, and also the coordinates for the bounding box around the assembly. Mass properties are calculated by Creo for a part or assembly of parts, and Syndea brings them over to SysML in the model transform. The list of value properties also contains two Creo parameters, modeled by and description. Bringing these over to SysML is optional, based on a Syndea setting. Back in the Cameo tool, I create a new block definition diagram and drag the sample assembly block into it, where the part and value properties are displayed. It has the Creo assembly stereotype. If I drag out the peg part property, it shows up as a separate block connected to sample assembly by a directed composition relationship, the black diamond arrow. This block has the Creo part stereotype. A new block also appears as an association block. It also has the name peg, but it has the Creo component stereotype, and its value properties are the translation and rotation matrix coordinates that represent the part position within the assembly. This approach uses the SysML concept of association block to hold the additional geometric information to fully specify the assembly. One way I can use these connections is to open the CAD models directly from the SysML diagram. Right-click the sample assembly block in the BDD, choose Open Connected Artifacts, and Creo is launched. I can also use these connections back in the Syndeia dashboard to compare and sync the two models. In the Connection Search tab, I can see that 3 new connections are being maintained by Syndeia between the CAD and SysML models. One for the assembly and each of the parts. If I right-click the sample assembly connection and choose Compare, the result is all green. Neither model has changed since the original model transform. Now I will go and modify the CAD model. I broaden the base part and save the changes in Creo and return to the Syndeia dashboard. Now we compare the connection for the base part and see changes in several of the mass properties, including mass, surface area volume, and the breadth of the part. We can repeat the process and see changes to some of the mass properties of the overall assembly because of the change to one of the parts. To update the base part mass properties, we go to the connection browser, select the connection for base, right-click and select Sync Target to SysML. Again, the comparison results are now back to green. However, we must also repeat the process to update the sample assembly's mass properties as well. Even though the mass properties of part and assembly are linked in the CAD tool, the corresponding value properties are not linked in the SysML model and must be updated separately. For a SysML Creo connection, it is not possible to create a Creo model from SysML blocks. This functionality is not available from the Creo API. Similarly, a reverse update, sync SysML to target, has no effect. Creo mass properties are calculated values and read-only, and they cannot be updated from the SysML model through the Creo API. Also, the CAD designer will probably not want the system engineer modifying part dimensions remotely in any case. Please contact our online help desk at www.intercax.com/help with questions or suggestions for improvement of the training resources.